All right, so the first one, what is the common denominator? Can you factor either denominator? No. Mom doesn't need to know that you're doing really good in that. That's why your head should be up watching. Maybe you might want to write little notes down or something, might help. Can I factor either numerator? What did you guys tell me? Or denominator? No. So, what do you do once you do factor numerators? How do you find your common denominator? No. Not what I said. Yesterday, I said you always look to factor denominators first, right? Don't worry about factoring numerators. And then once you have them factored, how do you write down your common denominator? What did I say yesterday? Whatever shows up, write down. Can I factor either one of those? You just told me no. So whatever shows up, write it down. So what's the common denominator? Right. If you can't factor them, you just write them down. This is doing this already. All right, so look at the original denominator. What did I do to it? I multiplied by x plus 1, right? Right. So what do I do to the original numerator? Multiply by x plus 1, the exact same thing. Isn't that what we did yesterday? Yes. Focus. What did I do to the second denominator? So what do I multiply x minus 3 by? Same thing, x minus 2. Questions? Do we understand that?
How'd you get the second set of functions since they're x plus 1 and x minus 2?
This stuff?
No, down top.
Here?
Yeah, how'd you get like the x minus 2 and the x plus 1?
Alright. I can't factor either one of them.
Okay.
So since I can't factor them, I have to write both of them down as the common denominator.
Okay.
Whatever shows up, you gotta write down. Yeah, when you factor, that's what we do, right? If you can't factor, you go to that step. Whatever shows up, you write down. Right.
And then no solve further from that? Like the numerator, you wouldn't make it 3x plus 2?
Well, we're gonna multiply, yes. We're not adding them, we're multiplying. This means multiply, right?
Yeah.
But yeah, we gotta go further. We're not done. Any other questions about how we rewrote both fractions? Okay, now, before addition, you always have to do multiplication, right? So I have to multiply these two binomials, the red ones and the two blue ones, right? By FOILing, right? So, x squared minus 2x minus 3x plus 6. 2x squared for first, outside 2x, inside 1x, last 1. Once I get my common denominator, it doesn't change until I make it one fraction, and then I might change it by simplifying, right? Combining like terms, what's 2x squared plus x squared? 3x squared, just combining like terms. 2x plus 1x is 3x, minus 2x is 1x, minus 3x is a negative 2x. 1 plus 6 is 7. You cannot factor that numerator. So we're done. If I could factor that numerator, I would factor it because I might be able to simplify. Actually, we're not done because we have to do the second part here. Identify any x values for which the expression is undefined. Right, x is not allowed to equal 2 or negative 1. So there's our answer.
What if we said x plus 2 or x minus 1?
Say that again.
Oh, wait, never mind. My bad.
Okay. Again, we're looking to see what makes those 0. That's what x is not allowed to do. Again, we call those restrictions on our variable. Okay? Because we can't have 0 in the bottom or the denominator of a fraction. Coli, pay attention. Okay, can I factor either of those?
Yeah.
Yeah, which one?
X squared.
Right, which is
X plus 4 and x minus 4.
difference of squares, right. Square root of x squared, square root of 16, plus or minus. So, what is my common denominator? What shows up? X plus 4 shows up, and x minus 4 shows up. X plus 4 showed up twice. Do I need to write it twice? No. What if I had exponents on those? Which one would I use? The higher one that showed up, right? So we don't have to worry about that. Okay, looking at the second fraction. Look at the original denominator, look at the common denominator. Is there anything that's changed? No. So do I change the original numerator? No, that does not change this second numerator. Okay? Now, x plus 4, x plus 4. What did I do to that original denominator? Multiply by x minus 4. So I got to do the same thing to the original numerator. We okay now? Rewriting our two fractions? Now again, here's subtraction, but this is multiplication here, right? So I need to distribute that x first before I can subtract. Okay, so we got x squared minus 4x. So combining like terms, x squared minus nothing is x squared, right? Negative 4x minus x is negative 5x. Nothing minus 36 is negative 36. Can I factor that numerator? What are the factors of negative 36 that add up to negative 5? Good. Negative 9 and positive 4. Do we see any factors, top and bottom, that are the same? Yes, plus 4, right? So what's our answer?
Minus 5x.
No.
X
X minus 9 over x minus 4. What are my restrictions?
4.
or a negative 4. It's way up there, I guess, huh? Because I got it down. But x cannot equal 4 or negative 4. It's up there, I think. There it is. Questions on either one of them? That's what we were doing yesterday, right? Okay. Some of you got to those where you had to find the common denominator because they weren't already the same and struggled. Okay, that's drawing out some struggle. We did what? 2 to 12? Even, right? Number 2 is 5x plus 1 over 4x minus 1. X cannot equal 1/4. Number 4 is negative 6 over 2x minus 5. X cannot equal 5/2. Those two should have been easy for you because they already had a common denominator, right? They're both minuses, I think. Yeah. Number 5, no, that's it, 5, 6. The common denominator or the least common multiple between those two would be x minus 5 and x plus 5 to the second. There's 2x plus 5s in that second one when you factor it, so you have to use that higher exponent. Okay. Number 8 is 16 minus 9 over 4 times the quantity 3x minus 3x plus 1, sorry. X cannot equal negative 1/3. Number 10 is 5x squared plus 8x minus 30 over 2x minus 5 times 3x plus 1. You couldn't factor either one of those, you had to write them both down. Your restrictions are x cannot equal negative 1/3 or 5/2. That was like that first one on the warm-up. And the last one you had to do, number 12, is negative, you could write it 2 ways. You could write negative x squared minus x plus 1 for your numerator, or you could factor out the negative 1 and put x squared plus x minus 1 for the numerator. Either one is acceptable. Your denominator is x plus 1 and x plus 3. Your restrictions are x cannot equal negative 3 or negative 1. Anybody need me to do any of those? Going over those two help, hopefully. Okay. No questions? We shall go back to where we left off yesterday. Okay, so we did the addition and subtraction part yesterday. Today we're doing the complex fraction part. All right, so these are examples of what we call complex fractions. Okay? So basically it's a fraction within a fraction. Okay? What did we do last week on the quiz when we had dividing two fractions? What did we end up doing? Multiplying by the reciprocal, right? So that's just basically what we're going to do here. We're just going to multiply by the reciprocal to simplify it. Okay, Wendy? All right, so I have a fraction over a fraction. That means this, right? Wrote it out long ways instead of as, you know. And what am I supposed to do with this second fraction? Flip it. So that's what they did. And then there's no common factors, are there? So we change it from division to multiplication. There's no common factors. So that's our answer right here. So there was nothing we really had to do but flip it. That easy. Not gonna ask you to find restrictions. Right, assume that all expressions are defined, so you don't have to do that part. The x cannot equal stuff. Okay? So again, this fraction is this one. And then this one here is here. So they just rewrote it. They write it like this in the book, but you can think about it like this and then flip. And do what we did last week from section 8.2. All right. Now here, this one, before I can add those two, I'm going to make it a single fraction. Before I can add them, I have to do what I did last night. Find a what? Common denominator. Can I factor either one of those? No. So what do I do if I can't factor? Just write them down. So my common denominator is going to be 2x. I like to put the number in front. If you put x2, that's okay, but normally we do it like that. So what did I multiply this first fraction denominator by to get this one? 2. So what do I multiply 3 by? 2. 3 times 2 is 6. What did I multiply this 2 by to get that? X. So what's x times x? X squared. Okay? So I like to put the x squared in the front. That's my fraction now. So here's the complex fraction. This is what it looks like right now. You understand that? I didn't have to do anything to this fraction. It's already a basic, it's just a fraction. We want to make two fractions into one, add or subtract if we have to do that first. Okay, so now, this first one, the top one stays the same. But the bottom one I do what with? Flip it. Can I factor any of these numerators or denominators? No. So, are there any factors that I can cancel? Yeah, you're right. Which one? The x squared one or this x one?
No.
This one. With this x or this x? The left one, right? This top right one with this bottom left. Because these are multiplication here, right? So it's a factor. Got the minus and the plus here, they're not factors right now. If I had an x minus 1 up top somewhere, I could do that. Or if I had an x squared plus 6 in the bottom, I could do the whole thing. Okay, so my answer is just x squared plus 6 in the top and 2 times x minus 1 in the bottom. Again, we don't have to worry about any restrictions for these. So we had to do an addition problem first. So we got the numerator to be a regular fraction, not two fractions. And then we multiplied by the reciprocal to simplify. Any questions? You're allowed to ask questions. You guys know that, right? It's okay. Andrew, you okay over there?
Yeah.
Well, we did that one already, right? Let's do that one. You guys try that one on your own, and then we'll go over it.
We might have to ask that question soon.
Well, you remember like, you
You get more tired when you go to bed early.
I know.
You're more tired when you go to bed earlier.
That's how I am. I want to sleep at 11.
I go to bed at like.
Oh, literally, like,
They're telling me to do right and left.
I hate that. I hate
Negative 2 times -4. What about that's 8? How is it better? You don't even know that.
We're supposed to do it this time.
You're not doing it right.
He was sitting right.
When you actually do the square 95 on the test, I want to tell you so bad. Oh my God.
I got 3 miles.
Jack had to go over and take the back.
My dad's. My dog's.
Where's he at?
Why does
I don't know.
X squared? I mean, it's
Yeah, Patty, like,
Fatty.
Really?
Just put her down.
Oh, so technically, like, if I just.
That is not the answer.
Probably the issue.
Unless they say, they got these, like, canceled out.
No, you can't cancel it.
But what if I did?
Well, come over here.
That's the difference of squares. X, you have to factor.
Good job. You actually did it.
When you cancel out 3 out of the.
What's left?
The answer is X.
No,
So that's it.
yes, everything's right so far, but if everything cancels.
They still cancel. But that's how they do the same.
I don't know, those either are.
Oh, so it's just. Because the X plus.
Okay, you guys are doing a good job. Watch.
How'd you get X? Yeah, you mean how I get one? One goes up there now.
Eyes up here, please. You guys okay with that?
Wait, hold on. Yes. Oh, yes. Wait, hold on. Yeah, wait, what? No. Yes, yes. Yes, yes, yes.
I just flipped it, right?
Yeah.
I flipped the bottom one, made a multiplication. Is there anything that I can factor? Yeah. So I got x plus 2 over x plus 2 times x minus 2 times x minus 2 over x. This I factored as a difference of squares. It's division, but we changed it to what? Multiplying by the reciprocal, right? So that's what I changed it. Okay? So do you see any factors that are the same? Yeah. Anything else? Yeah.
So we have X.
So if everything's gone in the top, is it 0 or is it? It's 1, right?
So we're still waiting 1 over X.
Okay?
What if we just put X?
You're wrong.
Boom.
Oh my God.
So remember,
So well.
you guys know this, right? 5 over 5 is what?
1.
Right, because 5 goes into 5 once, 5 goes into 5 once. It's 1 over 1, right? So that's what's happening here. The x plus 2 over the x plus 2, when I divide an x plus 2 into an x plus 2, I get a 1. When I divide an x minus 2 into an x minus 2, I get a 1. So it's 1 times 1. So there's still a 1 up there. Okay? All right. There's your homework.
Post notification on.